Hello, this is Allison Hatton, and today we'll be doing a review of the sifting property of delta functions. So, in case you don't know what that is, basically the sifting property of delta functions says when you have a delta function multiplied by another function in an integral, you basically just take whatever you have in with it and make it whatever it would be where that delta function is. So, we have 4 examples here for us to try. And our first one is the integral from negative infinity to infinity of cosine of s delta of s minus 4 ds. So our delta function has been shifted by 4, which means it's going to be at positive 4 on our x-axis. So at positive 4 on our x-axis is where our cosine will be. So basically what that's saying is the answer to this equation is the cosine of 4. Because we are just evaluating the cosine at the delta function, and the delta function's at 4. Now, our next one, we don't have anything with the delta function. We have just the delta function. So, our integral of the delta function is u of t. But since our delta is at positive 1, because it's negative 1, and it's always the opposite of what you think it should be, then our u function will also be starting at positive 1, so it's going to be at t minus 1. And our next problem has e to the negative 2x in our delta function. And this is being evaluated at t minus s ds. So that basically is saying that our delta function is going to be at t minus whatever we're evaluating it at. So this one's a bit tricky because of the way with all of our different variables and everything, but basically what it says is you kind of just input your new variable in the place of your e, your x variable. So you're going to end up with an answer of e to the negative 2t. Because you always replace the s with whatever you're evaluating at, your delta function will only be basically at t, wherever you're putting it in, because that's just how it works. So you plug in the t for the x. And then our last one is another one with the delta function is only in there by itself. But this time, we're evaluating from negative infinity to t plus 1 instead of negative infinity to t. So, because of that, when we evaluate this, we're going to have u of t plus 1 as what our delta function is being evaluated at. So, thank you for watching this video, and that's all.